Method of undetermined coefficients. So let's solve this non-homogeneous equation with constant coefficients. D squared plus 1 acting on y equals 12 times cosine square of x. So the general solution is y equals y sub c plus y sub p, where y sub c is the complementary solution and y sub p is the particular solution. First, we write the auxiliary equation of the homogeneous equation. That's m squared plus 1 equals 0, or m squared is negative 1, and m is plus and minus square root of negative 1, which is an imaginary number. So for imaginary root, y sub c is c1 cosine of x plus c2 sine of x. So next we solve for y sub p. So let's examine the right side of the equation, which is r of x equals cosine square of x. If you recall, cosine of a plus b is cosine a times cosine b minus sine a times sine b. If we have cosine x plus x, then we have cosine of x times cosine of x minus sine of x times sine of x, which is cosine square x minus sine square x. And sine square x is 1 minus cosine square x. So we have this plus this is 2 cosine square x minus 1. And this one is cosine of x plus x, or 2x. So solving for cosine square of x, we will have cosine of 2x plus 1 divided by 2, or cosine square x is 1 half of cosine 2x plus 1 half. So this r of x is the same as 12 times 1 half cosine of 2x plus 1 half, or r of x is 6 cosine of 2x plus 6. This is actually a particular solution of some homogeneous equation whose auxiliary equation will have these roots. Let's call it m prime. For this first term cosine, we should have roots plus and minus 2i, where 2 is the coefficient of x. And for this constant term here, x, that should be 0. So that's like having c1 times e to the 0. And this is just 1. So we have a constant c1. Okay, so now we write our y sub p. So we'll use a, b, c for the coefficient instead of c1 and c2, because this is already a particular solution. For this root plus and minus 2i, we should have a cosine of 2x plus b sine of 2x. And for this 0, we'll have c times e to the 0, or just c. Then we are going to substitute this to the original differential equation, but first we need to find the second derivative of y sub p. So the first derivative is negative 2a, 2 from the coefficient of x, negative sign is for sine of 2x, plus the derivative of this is 2b cosine of 2x plus 0. And then y double prime, or the second derivative, is negative 4a cosine of 2x. This becomes negative 4b sine of 2x. We need to add this and this. That's the second derivative plus y sub p. Okay. So if we are going to add that, that means this plus this will give you negative 3a cosine of 2x. Then this plus this is negative 3b sine of 2x. Then plus c equals the right side 6 cosine of 2x plus 6. Let's erase this one. So for the coefficients of cosine 2x, we have on the left 3a and on the right 6, and that will give us a equals negative 2. For the coefficients of sine, the coefficient of sine here should be 0, while on the left side is negative 3b equals 0, and that gives us b equals 0. And then the constant term is clearly c equals 6. We substitute these values here, so we get y sub p equals negative 2 cosine of 2x, b is 0, plus c, which is 6. And finally, our general solution is y equals y sub c, c1 cosine x plus c2 sine of x minus 2 cosine 2x plus 6.